Okay, back to Segmentation Wizard. This is the second Segmentation Wizard video. Let me start screen sharing. So what I've got here is I've got a data set of denim, which was scanned, microCT scanned by Rigaku and provided to us. Thanks for that. This example is often used to demonstrate the deep learning. We've got a nice example on our website of the segmented result. And the reason this is a good example is it's a little bit noisy, and these two classes, there's large fibers and small fibers, which you can see by eye. These are the small ones and these are the large ones, but you cannot distinguish them by any traditional thresholding or traditional segmentation methods. So this is a perfect example for deep learning, and we're going to be using Segmentation Wizard to train a neural network, a UNet model. So we go to Artificial Intelligence, Segmentation Wizard. So as you've seen in the last video, we immediately launch in that way a new context, a new window, which is the Segmentation Wizard context. The idea here, in this case, we're going to train. We need to paint one or more slices or frames, so we can create a frame like that, and we can then paint these pixels. We need to paint them into classes. We have, in this case, background, and now the second class is not plastic as we had in the Lego man before. In this case, we have small fibers, and we're going to add another class, large fibers. Right, so in this case, if we want to train a neural network, we need to mark all pixels in the slice. So the background is reasonably easy. We can use a 2D paintbrush tool. We can use the full paintbrush tool, or we can use local Otsu lower. So what this does is within the radius of the circle, it selects all the lower valued pixels as if it's thresholding. So it's quite easy to paint this black on the outside because that's much less than everything else. So that's obviously the lower side. We can care about the rest later. What I want to do, I will show you a simple way to add the rest of the background here, but later. Let's first get the small fibers. Oh, I've actually painted the wrong stuff. I want the background painted there. Let's just do that over. So depending on where you painting, it's going to find in certain regions that's over there. We still have some incorrectly labeled pixels. So what you can do in that case, you can use the highlight both. In that case, it's going to give you an option to have both the brush, which is toggling between the two. So in that case, you have a full brush and you have both of those. The shift is painting green, so adding green and removing red, and the control button allows you to do the opposite. So we're going to do, we're going to paint the large fibers now first. So let's see, let's make my brush quite large. Whoops, that's not correct. There's an undo button here, luckily. So for one step back, we can do an undo button. We want to paint the large fibers, in this case, using a local Otsu upper brush. That's going to be quite easy, like that. Or maybe my brush is a bit too big. So there we go. Oops, that's not correct. Let's undo that last bit. So the idea is this segmentation would take less time than painting each slice. So, and also there's some other advantages to using deep learning for multiple data sets and so on. we're not going to get into all of that here. I just want to show you actually in these videos how to use the tools. So you need to paint every pixel in a slice. In this case, you can use many segmentation tools. Whoops, that's again not right. So I'm just going to delete that. Okay. So there I've got a mistake on the small fibers. So these ones I need to do like this carefully. And again, there I've painted a large fiber as a small fiber. So we're basically providing ground truth here. So let me paint these guys. There we go. And these guys, the better the ground truth is, the faster and better the neural network models will become. So something that can be useful at this stage is to change the opacity. So you can have a look at the actual data and make sure you're not making a mistake somewhere. And also, if you make it bright, you can see some incorrectly labeled pixels more easily. Okay, so I think that's not bad. What I want to do is, let's just add that. There's an unlabeled fiber. We want all fibers labeled. That's not correct there. Hang on. Just make your brush smaller, and then the O2 works better. So the O2 brush depends on how big the search distance is, because that's depending on how many surrounding pixels are included in that selection. All right, so we can clean it up like that. The point is that the shortcut I wanted to show you about earlier is, let me just add that. So the shortcut I wanted to show you earlier was about adding all the background pixels at the end. So what you can do is you click on background, right click, add all unlabeled voxels to class. So now we have all pixels in this image labeled, and we have, oh, there's something going on over there. That's not right. We just need to fix that. And we need to use a brush which is full for that. Okay, so there we go. Now we have not a bad training frame. This is a training frame, so we select that, and now we can go to another frame like this, and we can look at this, and we can add this as a monitoring frame. So we could have painted more slices, but let's do one to get started with. We go to train, and now we don't want to do a quick start. We want to go directly to a UNet. So let's do the better. Okay, no, for time, let's do a single model 1. So a single model 2 is usually a good choice, but I'm going to try to do things a bit faster here in the demo. It's still training a UNet model, and what comes up here is the UNet training window. It shows you all the training parameters, the model description up here, and it's showing you all details of the training. So we will also see a preview frame, a monitoring frame, because I selected the second frame to monitor as training progresses. So the first preview frame will probably not be great. But let's have a look. Okay, so that's the preview frame after one epoch. We've got large fibers red, small fibers purple, and background. There's a bit of incorrectly labeled small and large fiber getting mixed up. Let's see if it is improving. Okay, I guess it's slightly better on the large fibers. It's missing some small fibers now, calling small fibers large fibers at the moment. This inference slider shows you the inference with more and less opacity, so you can change that. And the same thing with the input itself. So you can reduce the opacity or increase the opacity of the underlying data as is your preference. So as you can see, it is getting better. These values are dropping here. It does visually seem better. And that's really actually quite good. I quite like that one. It's got most of the small fibers and large fibers correctly classified. Yeah, that's actually pretty good. So I think I'm going to stop at this point. Let's just click the stop button there. And so what we can do is we can let's see, we can make it visible, or we can click this little button to make the model visible actually. So it's going to predict on this training frame, as we've just seen in the preview anyway as well. So if we now look at the monitoring frame here, that's actually quite nice. I want to promote that. So this frame here, what we can do is we can slightly fix it up. So we can, let me show you the exclusive brush. I didn't demonstrate that quite nicely before. So here we want to classify these as large fibers because the boundary of the small and large fibers is roughly here. So what I want to do is I want purple and red to change. But so I click hold control down and click on each one of those classes. In that way, I will be able to access a brush with a full brush with control and shift, allowing you to selectively change those without doing anything to the green. So that's quite a nice tool here to fix up the data where the prediction wasn't perfect, and just to refine it a little bit really. And while still making sure all pixels are labeled. So over there is the opposite what I want. So there I want to add a little bit because they had to. Okay, that's looking good. I think it's difficult to say really, but I think that's pretty good. And in this way, the model will get stronger because now we have, if we look at this one, this is what we originally provided. Nothing changes to that because I fixed it as a training frame. This one we're now also happy with. Let's fix this also as a training frame. And we can go to a third frame. Let's take it quite far away. Let's have a look at this. Let's have a look at this as another frame and as a monitoring frame for a next round of training. So we continue to train. Let's go. So it's actually applying that model prediction here. So you could actually use the same, it's actually predicted already using the existing model. So you could, let's do that. Let's promote that. And also use this for the next round of training. So let's go again with a brush, again, the purple and red. So we need to click here again. There we go. And oops, I was scrolling by accident. Let's not do that. It's pretty good here. I don't see any problems here really. Actually, that's pretty good. So now let's use this also for training. And let's go to another section. So let's see how this would turn out as a monitoring frame, because here we see clearly small fibers, there's some small fibers, and large fibers are quite clear. So let's see how the model can be trained better on this. So let's have a look at what is the current prediction. Actually, the current prediction is quite good. It's making a mistake here. So let's see if training a new model would fix that up. So if we do a monitoring frame, and now we train again. So in this way, we're going to see if that little section, which is actually large fibers, would be improving and being classified as large fibers, where it's at the moment with a model being classified as small fibers. So the idea here is to show you how to add data and to label the pixels clearly in Segmentation Wizard. And basically you have a lot of all the 2D segmentation tools available. I've only shown you the brush, the full brush and the Otsu brush, lower and upper. And also right click to add unlabeled voxels to class. There's also the smart grid tool, which is quite useful in 2D. It does a local watersheding, which you can try out on it works quite well on some kinds of data. And there are some other tools, of course. You can also manually just paint by using the full brush and zooming in and out. So this is the first epoch. Let's have a look as it progresses. You will notice right over there, you can actually zoom in on the preview. That's quite nice. I didn't know that. So I'm actually quite new to these tools, so I'm definitely not the expert. My role here is just to show you where the functions are and how to get how to use it. So that's why I'm not discussing in detail all the parameters. And also that's why I've only noticed here for the first time that I can zoom in on the preview, but that's quite nice. You will be similar to me, often surprised at the functionalities and the flexibility in Dragonfly. It's really quite powerful. So from the first epoch to the second epoch, I noticed a section here that was in the first epoch classified as small fiber, as a purple section, which is now red, which is good. And there's a bit of this section here is large fiber actually. And actually now it also added some red here where it was purple before. So that's good. I don't know if I'm going to run this through many epochs. This demo is actually not good in that sense, because you need to wait for these models to train properly. I would suggest to wait at least 10 epochs, if not more, especially after it has plateaued. You might still want to wait even more, because sometimes it still improves a lot. So obviously that's not good. That's not a good result there, but that's why you would want to leave it more. I'm quite 90% confident the next epoch will be much better. These jumps are quite normal. Okay, definitely better. But yeah, as I said, this is going to take too much time. The point is similar as in the last video, you train it until you are happy. If it's not improving anymore, there will be early stopping taking place. Like at the moment, it's saying early stopping will take place in 12 epochs if it doesn't improve further. And often it does improve. So it will run through at least, I think, maybe 40 or 50 epochs, and then it will stop by itself. Or you can manually stop it, do early stopping when you're happy and you think you've trained enough. You can also select manually to not stop at all, but and just stop only when, or like when you have when you're leaving it overnight or over a weekend, for example, that can be useful sometimes. I'm just going to stop it here. At this point, I'm not going to continue it, but as I said, as I showed before, you can, when you exit, it's going to ask you about this model. Yes, I want to save it. Let's give it a name. We call it the FIBSEM model 1. Publish it. Okay. So what you can do now is you can go to Segmentation tab and you can go to Segment with AI. So you can go to that particular model, which, let's see, where is it? FIBSEM with model 1. So you can apply a preview to this slice, or you can apply a segmentation to all slices at that point. This is on the segmentation tab. So that's not bad, actually pretty impressive, I think. It's got a few mistakes here, but that was because we didn't train long enough. We did have enough frames, I think, but we just didn't train for a long enough time. And that's basically how Segmentation Wizard works. I'm going to stop this video here, and we will continue the next video on a Segmentation Wizard regression model. The current one was a segmentation model. So you go from an image to a segmentation like this, with a multi-ROI. With the regression model, you go from image to image. So that's it.